Alright guys, these are some of your 6.2 homework problems. I just wanted to show you how to use that calculator feature to do some of these. So a lot of these are dealing with thermometers. Alright, thermometers in Celsius, the water freezes at 0 degrees Celsius. So a lot of these are these thermometer questions just so we can have a mean of 0. So it should be expected that the thermometer I'm using freezes water, or the water freezes at 0 degrees Celsius. So anyway, they're made to have that reading, but because error, humans make them. Sometimes they're not exactly calibrated correctly. So anyway, the mean is 0, standard deviation is 1. That lets us have a z distribution. So that's why it's telling me that information. Okay, now find the probability randomly selected thermometer reads less than 0.08. And draw a sketch of the region. So 0.08, that's 0, that's 1. 0.08 is going to be, virtually 0. It's going to be way close to it. So I'm going to just put it right there roughly. Now what am I shading? Less than. So the direction that I would shade is going to be back in this direction. Let me grab this big one. I'm shading back in this direction, and I'm going all the way down into the tail down here. So all the way down back into the tail. Alright, that's what I'm looking for. I'm looking for this area. Alright, remember, area is probability now in this section. So according to the calculator, what I've been telling you guys is to use, for areas in the normal distribution, you use the normal CDF, right? And you put in, the very first thing you put in is where does the shading start. So this starts when it's way over to the left like that. We just put in a bunch of 9s after the negative sign. And where does it end? It ends right there at 0.08. Oops. 0.08. So negative 999 comma 0.08. Close, and we get just something slightly above 50%. So 0.5319 to 4 decimal places. Right, that's our area right there. All right, and just pay attention to how many places they tell you around. Usually it's 3 or 4 for these problems. All right, same type of problem between negative 0.06 and 1.27. So again, there's my 0 line right there. So negative 0.06 is going to be very close to it. All right, and 1.27, there's 1, so 1.27 will be roughly around in that area. Again, the sketch, it doesn't really matter how accurate you are. I'm not going to go through and measure and tell you that you're wrong, here. It's just a sketch to get what do I need to put into my calculator. So this is what I'm looking for between these two numbers. And these are the easiest ones to do on the calculator. They're the toughest ones to do on the using the table, but with the calculator, it's just simply normal CDF, lower number, upper number. So negative 0.06, comma 1.27. Alright, so 0.4218. Oops, 0.4219 if I rounded it correctly. Alright, now if it just gives you this notation, this is another way to say between. So when you see the z between two numbers, that literally means the probability z falls between these two numbers. So we got symmetry, there's negative 1, negative 1.37 will be around there. Positive 1.37 will be around there. Alright, and then we're looking between these two values, the area between these two values underneath the curve. So this is what I'm looking for. Alright, always a good idea to shade, make a sketch of a bell curve and shade what it is you're looking for, because again that sets up where does the shading start. It starts at negative 1.37. Where does the shading end? Oops. It ends at positive 1.37. Alright, and I do want to point out that if you ever put your numbers in backwards, meaning like if you put in the positive 1.37 first and the negative 1.37 second, you're going to get that same area, but you're going to get the negative of it, the opposite of it. And that has to do with calculus. You don't need to know why, as far as calculus goes, why you'd be getting that, but just know that if you ever get a negative out of the normal CDF, it's because you have your lower and upper number inverted. Alright, so that was positive 0.8293. Alright, and then this one, careful with the wording of this one, negative 0.65. So there's 0, there's negative 1, negative 0.65 is roughly there. Positive 0.65, so same place on the other side. Alright, but if you look carefully, this is saying less than this. So less than this number or greater than this number. Less than this number is this way, and the greater than the 0.65 is this way. Alright, so we're not finding the area between them this time. We're finding the area outside of those two numbers. Alright, a couple ways we can do this. One, I can do the normal CDF 2 times. This starts at negative 999 and ends at negative 0.65. Alright, and then add to that plus this one, which is the normal CDF of 0.65 comma, and then it goes up to positive 999. So that's one way. Or I could have just used the symmetry thing, because these numbers are opposites. I could have found the area of the lower one and then doubled it because of the symmetry. Alright, it gives me the same thing. And then the last thing I could do is found the area between them and subtracted that from 1. So any three of those will work. They're all going to give you the same thing. It's just whatever intuitively comes to you to do would be the way that you would do it. Okay, but 0.5157 is the answer no matter which way you do it. Okay, and half of that's down here, half of it's up here. Split in half because of the symmetry. Alright, now another thing that you do here in this chapter, or in this section, is instead of here's a number or two numbers, find the area between them, you get an area to the left, right, the percentiles, or an area to the right sometimes, and you have to find the number that has that area to the left of it. So the 90th percentile, that's going to be way up here. Okay. And again, it doesn't matter where you put your mark. I'm not going to look and see, well, it should have been between 1 and 2, or it should have been between 2 and 3. It doesn't matter where you put your mark, just as long as you get your areas right. So there's where I'm going to put my mark. And the 90th percentile means that 90% of the values are below it, which is another way to say that this area right here is equal to 0.9. Alright, so the area to the left equals 0.9. Well, that's inverse normal's job. Right, remember, inverse normal, second vars, inverse normal, it takes in area to the left, and it'll return the z-score that has that area to the left. So 1.28. So there's 1. I'm way over here to where I shouldn't be, but that's the z-score that we're looking for. Right, that's the 90th percentile for these thermometers. 90% of thermometers are going to read less than 1.28 degrees when water boils, basically. That's what that would interpret here in this one. Right, now if this is 90, this up here is 10%. That's in the upper tail. Okay, so we're splitting apart the lower 90 from the upper 10. And that's what this last thing's saying. Now, this Z with a 0.05, this is what their book refers to as Z alpha. So you'll see the book call it Z alpha. Alpha is the area to the right of some Z-score. So when you see Z alpha, it means the Z-score with an area to the right of it of whatever alpha is. Alright, so that's the Z-score with alpha is the area to the right. So I'm going to go over here again, just like I did before. I'm just going to arbitrarily pick a place to make my shading. And I know this shading, the area has to be 0.05 to the right, right, because that's what Z alpha means. So 0.05 is my area to the right. Well, that means that 0.95 is the area to the left, and the area to the left is what inverse normal takes in. Alright, so if I'm needing to find that, then I need to put in this 0.95 into the calculator. So inverse norm 0.95, and there is my answer, 1.64, roughly 5 to 3 decimal places. Alright, and then if I don't want to do Z01, then now I'm even further out in the tail. Now the area is only 1% in that right tail. So that area to the left is 0.99. So now I'm going to do the same thing, just hit second enter, bring back the last thing I did. That's 0.99, that's 2.33 roughly, to 2 decimal places. Sometimes they'll have you round to 2, sometimes they'll have you round to 3. It has to do with the table while we round it to 2 or 3. But anyway, that's how you use your calculator to find these. Now these things right here are called critical values. Some books refer to them as critical numbers. That's more of a calculus term, so I call them critical values. But they are going to be critical to what we're going to be doing in chapters 7, 8, and 9, or 6, 7, and 8, sorry. Because they are going to be, we've been talking about all along that this value that we consider rare, like 0.05 is what we've been considering rare, it's going to be eventually able to change, and we're going to be able to control what we want to consider rare. Well, if this is what I consider rare, this is the corresponding number of z-scores I have to be away to be considered rare. So it's not always just going to be 2 z-scores, or sorry, 2 standard deviations. It's whatever this critical z value is. It's not always going to be 0.05 that's considered rare. It may change. We may want to consider 0.01 to be rare. And now we need to be a little bit more than 2 standard deviations away from the mean. So these critical values are going to play a big role in what we're going to do later. So it's really important that you take the time to understand those now.